So guys, let me check my voice is audible or not. So guys, let me check my voice is audible or not. Yeah. Uh, Actually, I started morning, but it went somehow misleaded by my old students. So let's start revision session for the JEE mains. Particularly in this session, I'll deal all the first year topics with the basic content and with all the needed formulas. I'll discuss every chapter now. So if you watch through live, okay, or else if you can, if you're watching later also, you can make it fast forward and you can watch it like, okay, you can understand. If you know the what are the topics, you can in the 2x speed or 3x speed you can listen them, okay. So now here let's start with the content, units and measurements. So first let me give a quick review. Units and measurement, units and dimensions and measurements, right? Units and dimensions. Yeah. First topic is about units and dimensions. So first, let me give you what is a physical quantity. Physical quantity, in the quantity that which can able to measure is called physical quantity. For example, if anyone ask you your height, you can able to measure it. Your weight, you can able to measure it. Time, you can able to measure. Speed. So like that, there are many quantities which we can able to measure and express in terms of numerical numbers. That is called physical quantity. And there are few quantities which we can express but we can't measure them. For example, feelings like love and friendship and angry, etc., right? These and all we can express but we can't measure them, right? So those are our non-physical quantities. So coming to here, in a basically in physics there are seven fundamental physical quantities. How many? Seven fundamental physical quantities are there. So they are called fundamental physical quantities because they don't depend upon any other physical quantity. That is why they are called fundamental physical quantities, okay. And after these two supplementary physical quantities, right, after this remaining, except these nine remaining, every physical quantity is derived physical quantity, means those physical quantities derived from the fundamental physical quantities, okay. So here the units of fundamental physical quantities are called fundamental units, right? Let us see whatever those seven fundamental physical quantities. So first fundamental physical quantity, length, or let me take with the mass, okay. Mass is the first fundamental physical quantity. And yeah, mass, it's a SI unit is kg, and CGS unit is grams, and dimension formula we indicate with m. Okay, and then next, and then next, the second physical quantity is time. Okay, after mass, we'll take the second one is time. So coming to here, seconds, CGS units, SI both are seconds, and then we indicate T. Okay, now this is the symbol for dimension formula. I'll tell you what is dimension formula also. And after time, let me take length. Coming to the length, meters and centimeters is just the CGS unit, and then symbol is L. And after length, we'll take temperature. For temperature, SI unit of temperature is Kelvin. Okay, and then CGS unit degree Celsius, and then eta is the unit of symbol. Casually we use theta, because if you take T here, you can confuse for time and temperature. Okay, next, after temperature, let's go with current. Okay, this is also fundamental physical quantity. Ampere is a SI unit, and next is symbol is nothing but A. Okay, and then next, after current, let's take intensity, light intensity. Okay, na? Sorry, light intensity. Clear, intensity. Okay, light intensity. Here it's serious unit of candela. Okay, so SI unit is candela, and then serious units no need for this, and symbol is CD. And after light intensity, the next one is amount of substance. Okay, amount of substance. Coming to the amount of substance, if you observe moles, okay, na? The amount of substance will measure in moles. So mole, and symbol also you can take it as a mole. Okay, na? And now these are the seven fundamental physical quantity. They are called fundamental physical quantity because they don't depend upon any other physical quantity. Okay, there is a reason why they are called fundamental physical quantities. And remaining all the physical quantities will be derived by using these seven fundamental physical quantities. Okay, so I told you two more supplementary physical quantities, right? So now the first supplementary physical quantity is nothing but angle. Okay, now so the first supplementary physical quantity is angle. Its unit is radian. Okay, let me give you a small brief about this because it will be useful in many places. So here, for example, the angle between any two planes or any two lines. Okay, now for example, these two are the two lines. If you observe the angle subtended by these two angles, these two lines, you can take it as a plane angle. Okay, so now here, if you take this, if this arc length is L, the radius is R, then here angle is equals to arc length by radius, or else arc length is equals to angle into radius. Very, very important formula these are. Many places will get derivation. Next, now one more is a solid angle. Okay, solid angle. Coming to solid angle, the units of solid angle is steradian. Okay, steradian. So here the angle subtended by the, not it's not a one dimensional angle, 3D angle, the three-dimensional angle between around the some space. Okay, for example, like if you take ice cream cone, if you take, it has some 3D angle, na? That 3D angle is called solid angle, right? This is the surface area. Okay, so you can able to cut the watermelon in this shape, right? In the cone shape, right? Then at edge, how much angle it is making. This is called solid angle. Okay, this is a symbol that we indicate to the solid angle. So now here, solid angle is equals to, if the surface area is A, right? Then if the radius is R, then we can take it as A by, we can take it as A by R square. This is the formula for the solid angle. Okay, na? A by R square. Here, one radian in the sense. For example, let me take, I'll convert small important derivation. Here radius is r. Here a radius is r. Now what you have done is you covered the same r distance. Whatever the length of the radius is there, the same length of the arc length also is there. Now the edges of this part, which part it is? The arc length is equals to radius of the circle. Then the angle subtended by such arc length is called 1 radian. Okay. Here 360 degrees is equals to 2 pi radians. Okay. Remember this also will be useful. 360 degrees is equals to 2 pi radians. And then let's come to the derived physical quantities. These are all about the fundamental physical quantities and no, not green. Oh, sorry. These are about the fundamental physical quantities. Just a minute. Yeah. So now let's talk about the derived physical quantities. Let me check once again how the streaming is going on. Yeah, it's fine. Going well. So coming to fundamental physical, I mean derived physical quantities. Coming to derived physical quantities, what we are doing is let's take derived physical quantity. Yeah, sorry. Yeah. So coming to derived physical quantities. These are the physical quantities which depends upon fundamental physical quantity. For example, if you want to measure area, area can be measured by using length into breadth. Here these two are length only, right? So here I can in the symbol form I can write L square because length is let's say length breadth also is the length, right? Then you'll get L square. Here what I'm saying is derived physical quantity area derived from the fundamental physical quantities. If without using these fundamental physical quantity, you cannot derive this quantity. Am I right? So that is what is called derived physical quantity. And here derived physical, I mean, if you observe carefully, to derive the area, I have utilized length for 2 times. Okay, then its dimension is 2. uh, So here what I can tell is dimension in the sense, dimension formula in the sense nothing but how many times does fundamental physical quantities are raised to represent those physical quantities. Okay, na? For example, if I take volume, right? If I take volume, what happen? Length into breadth into height, right? Then you can write L cube na because length both are distances only. So L cube here the fundamental physical quantity length raised for 3 times to represent the volume physical quantity. Okay, and next if I take density is equals to mass by volume. Fundamental, I mean the dimension of mass is m, for volume it is L cube, so I can write m L to the power minus 3. So here it is the dimensional formula of density. Here to represent to derive the density, I have used mass for 1 time and length for minus 3 times. So by using these dimensions, I got a density. Mean here these two are the fundamental physical quantities. These two are raised for 1 time and minus 3 times to represent the density. Clear? So this is about the dimension formula. Next, after density, if I take a speed, right? Let me take speed or velocity. If I take velocity, distance by time, that is equals to L t power minus 1. And next, if I take acceleration, change in velocity by time is called acceleration. So that velocity in the sense L t power minus 1 by t, that is equals to L t power minus 2. This is about the acceleration. Now I will use force. F is equals to ma. right? So coming to F is equals to ma. If you observe carefully, the dimension formula of force for a mass it is m, for acceleration L t to power minus 2. So this is the dimension formula of force. And let's go with the work done. Work done dimension formula is force into displacement. For force, this is the dimension formula. Mass L t power minus 2 and for displacement L. So I can write ml square t power minus 2. Okay, ml square t power minus 2 is the formula for work done. For example, if you take kinetic energy, any energy, right? Half mv square. So m in the sense this is what, and v square in the sense L t power minus 2 whole square. So ml square t power minus 2. So here if you observe carefully, work dimensional formula and energy dimensional formula both are same, right? And next after this, like this, if you want any physical quantity, you can derive those equations. Okay. So now here one more, a few more constants will take. For example, dimension formula of gravitational force, right? What is here universal gravitational constant it is. So some constants also will have dimensional formula. You know, not all. For example, if you take a refractive index of light, I mean medium. Okay, na? So here c by v na. So this is speed, this is speed. So what's happening? It is unitless and dimensionless. So here it is a dimensionless quantity, right? At the same time, like there are few constant values which have dimensional formula. In the if you take gravitational force, it has dimensions. So what is the formula for a gravitational force? Actually, G is equals to G m1 m2 by r square, right? From this, what you can do is you can take G value. G is equals to force into r square by m1 m2, right? If I write the dimension formula for the force, mlt power minus 1, sorry, mlt power minus 2. This is the dimension formula of force, and L square for the R square and M square for the masses. Now from this, M to the power minus 1, L cube T power minus 2. This is the dimension formula of G. One more constant we will take. One more constant we will take for dimension formula. Let's take not G. Planck's constant will take. Here, simple equation E is equals to h v u, right? Here, frequency is nothing but reciprocal of time period. So from this, I can take E is equals to h by t. So from this, h is equals to E into T, right? Now, H is equals to what is energy dimension formula? ml square T power minus 2 into T. So that you will get ml square T power minus 1. This is the dimension formula for Planck's constant. This is the dimension formula for Planck's constant. Hope understanding, right? So like this, whatever the dimension formula they give, you have to find by using the main formulas. Okay, na? So now here after this, for example, coming to the second year question, like they'll ask you dimensional formula for the epsilon naught permittivity of a medium, right? So the electrostatic force is equals to 1 by 4 pi epsilon naught q1 q2 by r square. So here if you want epsilon naught is equals to 1 by 4 pi f into q square by r square. Okay, q square by r square. Here you should remember what is the dimensional formula for the charge. What is the dimensional formula for the charge? Here if you take a charge is equals to, for example, if you take current, I is equals to q by t. Am I right? From this, q is equals to I into t. So for current, a ampere. Am I right? Ampere into for t time only. Okay, na? This is the dimension formula for current. Okay, now clear. So now, yeah, Ayush, Chobe, I'm fine. Thank you. What about you? Yeah, right. Next, Nana. So now here, this is for this is the dimension formula for uh sorry, yeah. This is the dimension formula for current right now. So now here from this, if you take uh, if you take epsilon naught right now, for q we have found dimension formula now. So for epsilon naught 1 by for force m l l t power minus 2. This is for force. For charge a into t by for r square, in the sense it's a distance, right? So that we will take l square. So from these you can write dimension formula is m to the power minus 1. Okay, m to the power minus 1. And next, let me check how the go live is going on. Yeah, that's fine. Yeah. So now here, if you observe, m is equals to nothing but what I can do. If you take this m denominator to numerator minus 1 and l into l square, l to the power minus 3, and then a t power minus 2. If it goes up, then it becomes plus 2 into 80. So now I can write it once again. Dimension formula for epsilon permittivity is equals to dimension formula for permittivity is equals to what I put it. It is like m to the power minus 1, l to the power minus 3, e to the power 1, and a to the power 1. So this is the dimension formula for q. Sorry, here q square is there, right? Then we have to do square square. Yeah, I forgot this. So square and square. So now what happened, Nana? Here then you will get the dimension formula like m minus 1, l power minus 3, and then t power 4 you'll get. T power 4 you will get, and then a square. So this is the dimensional formula of epsilon naught. So hope you understand how to derive all this, right? Next, after this, I told you already some constants have a dimensional equations. For example, G and epsilon naught. This is, and if you want one more, you can take a dimension formula for R also, universal gas constant. This also has unit, Nana. So you can derive it like a famous equation PV is equals to NRT. By using this equation, you can derive. Okay, so like that, whatever the you want, not only for this, for Boltzmann constant, for all this, you can derive the equations. Okay, na? So next, after these dimensional formulas, uses of those dimensional formulas. Okay, uses of those dimensional formulas. For example, if you take a first point is principle of homogeneity. Sorry, principle of principle of homogeneity. Okay, so principle of homogeneity in the sense nothing but for example, if you take if you get equation, if a is equals to b plus c, it's an equation. Okay, here whatever the dimensions for the a, for b, for c also same dimension formula should be. For example, if I take I mean very simple, you can able to add a similar physical quantity. For example, you can able to add length to the length, but you cannot add length to the time now. Am I right or not? So that is why here the principle of homogeneity is telling you could able to add only same physical quantities. So for example, if you get equation S is equals to ut plus half at square. For example, I'm saying whatever the dimensional formula for S, for ut also will be same dimensional formula. For at square also will be same dimensional formula. Okay, na? So for example, if let us try to find out it is length, right? For length dimensional formula is L. For ut, u is initial velocity. For initial velocity dimension formula is L t power minus 1, and for time it is t. Then L, that is only it becomes 0. Only L is the dimension formula. Coming to this part, if we take this part, acceleration L t to the power minus 2 and t square. So that what happened? L here also getting the same dimension formula, right? So principle of homogeneity is telling that you can able to add a similar physical quantity. Addition or subtraction is possible with only similar physical quantity. Okay, so that is why whatever the physical quantity it is, the resultant of this gives you the same physical quantity. The resultant of this also gives you same physical quantity. Okay, now? So for example, if you take based on this van der Waals equation, PV is equals to nRT is the ideal gas equation. Na? For real gas equation also, for real gases also there is one equation we know very well. Okay, na? What is that van der Waals equation? In the van der Waals equation, many questions they asked previously. Okay, na? In the van der Waals equation, many questions they have asked previously. So what is the van der Waals equation here? If you observe van der Waals equation, P plus A P plus A by V square per mole I'm giving. Okay, now P plus A by V square into, right now, PV is equal to nRT, modified pressure and modified volume. Means V minus B is equals to nRT. This is the, sorry, I said it for 1 mole now. So PV is, this is a van der Waals equation. This is the equation for ideal gases, and this is the equation for real cases. Now, in this, they will ask you what are the dimensions of A comma B. Here, A comma B are constants. Right? At the same time, in many questions, they ask what is the value of A by B, what is the value of AB, like that of they ask. First of all, we have to find out the dimension formulas of A and B. Okay. In order to find out a dimensional formulas, what you will do is multiply P into V, PV plus A into V, A by V square into V, okay, and then plus A by V square into, sorry, let me go with proper order only, you will confuse again. Okay, so for example, what we do is P into V, PV minus P into B, okay, and then plus A by V square into V minus A by V square into B is equals to RT, right? So here, what I'm saying is, whatever the dimension formula for this term, the same dimensional formula for this term also, same dimensional formula for this term also, same dimensional formula for this term also, and same dimensional formula for this term also. Am I right? So now P is pressure. Pressure is equals to nothing but force by area. Force in the sense MLT power minus 2. Force, pressure is force on area. Area in the sense L square. So I can write M L to the power minus 1 T power minus. This is the dimensional formula for the pressure. And coming to the volume L cube. Now I'll make PV is equals to PB. Dimensionally only it is possible. Okay now. PV is equals to PB. Pressure cancel. So for B dimension formula is equals to L cube, right? The same way, if you want a value, I'll take this PV to the this one. PV equals to A by V because square V get cancelled now. So then you'll get that, right? So now here if you observe carefully, for P, I want A na. I want dimension formula for A. A is equals to PV square. P in the sense ml minus 1 t power minus 2 and v square in the sense L to the power 6. So m L to the power 5 t to the power minus 2 is the dimension formula of A and B, right? Now they'll ask you A by B value. If they ask you A by B value, then you can write A by B is equals to m L to the power 5 t to the power minus 2 by B in the sense L cube, right? Then you'll get m L to the power L square t power minus 2. Wow, it is equals to energy. So A by B gives you equal dimension formula of energy. Like you can answer the questions, right? Hope you understand well. And next, let's come back to the next use of dimensional formula. Let me check how the streaming is going on. Yeah, it's fine, going well. Right. So after this, next usage. Sorry, yeah. After this, conversion of units. It helps a lot to convert the units from one system to another system. Okay. Na? Second major important use is conversion. So coming to here, you convert it like this. For example, if you have conversion of units in the sense uh, physical quantity. Okay, now a physical quantity always indicate with the numerical into its unit. For example, if you go to the shop, you'll ask 1 kg. 1 in the sense numerical, kg is unit. So here, a physical quantity always represent in the form of n into u. N into u. Here, n is nothing but numerical number and u is unit. If you observe, for example, if I take 2 kgs, in this 2 kgs, 2 is the numerical and kg is the number. Sorry, kg is the unit. So here, what I can tell is numerical is, unit is inversely proportional to numerical. Because, for example, 2 kgs, here 2 is in kg is a unit. So if you observe, I can write the 2 kg as a 2000 grams. Here, this is numerical now, and this is unit. When the numerical is increasing, unit is decreasing. For same, okay na? So when the unit is increasing, numerical is decreasing. So for this relation is u inversely proportional to n. Okay na? So from this I can tell that un is equals to constant, right? And I can also write u1 n1 is equals to u2 n2. So by using this formula, you can able to convert many physical quantities from one system to another system. For example, let me take 1 Newton is equals to how many dynes. Here, let me take 1 Newton is equals to how many dynes. Here, if you observe carefully, Newton is the SI unit of force. Dyne is the CGS unit of force. Am I right? So here from this equation N1 is equals to 1, U1 is equals to Newton. What is the dimension formula for the Newton? For Newton dimensional formula is force, na? It is Newton in the sense force, right? For force, M L T power minus 2. Okay, now this is the unit formula. So here I can write U1 is equals to M1 L1 T1 minus 2, right? At the same time, U2 is equals to M2 L2 T2 power minus 2. This is the unit for in CGS unit. Here, let us find out first of all relation between the M1 and M2. M1 in kgs, right? M1 in SI system, M1 in kgs, and so the in CGS system, M2 is in grams. Now I can write M1 is equals to 10 to the power of 3 into M2 because 1000 grams is called 1 kg. So in the place of K 10 to the power of 3 I will write, in the place of gram I will write G, M2. Okay, and next similarly L1 is in the meters and L2 is in centimeters. Now I can write here L2 is equals to centi in the sense 10 to the power minus 2, meter in the sense L1. Am I right? So this is the relation between L1 and L2. And then time, whatever the system it is, CGS system, SI system, whatever the system it is, units of time is same. Okay. So now here, if you observe, what I can do is I will substitute all these in this formula. What is the formula that I'm getting? U1 N1 is equals to U2 N2. I want to find out N2 value. Okay. N1 unit. Sorry, I should write like okay na unit and sorry N1 U1 is equals to N2 U2, right? I want to find out N2. So N2 is equals to N1 U1 by N2. That is equal to what is N1? N1 is here nothing but 1. 1 into what is U1? This is U1, right? M1 L1 T power minus 2 by M2 L2 T to the power minus 2, right? Now here M1 by what is M2 here? I can write M1 as a, yeah, I can write M1 as a 10 to the power of 3 M2, 10 to the power of 3 M2 by M2 into, and L2 as a L1 by L1 by L2 na, L2 as a 10 to the power minus 2 L1, okay, and then time T1 and T2 as a T1, both are same only na, here minus 2 is there, right? So now let's solve this. M1 M1 L1 L1 T1 T1 get cancelled, then 10 to the power of 3 into, if you take into the numerator 10 to the power of 2 into 1, that means 10 to the power of 5. So you got N2 value as a 10 to the power of 5, which I can tell numerical value in the second unit, means I can tell that 10 to the power of 5 dynes, okay, means 1 Newton is equals to 10 to the power 5 times. This is how you can able to convert one system to another system units, okay na? Next example is we can able to create the new relations, okay na? We can able to create the new relations. If you take, if you take if you, for example, let me give you for example, there is a physical quantity t nana. Now I want to find out time in terms of acceleration due to gravity, I mean universal gravitational constant, Planck's constant, and speed of light. By using these three terms, I want to find out formula for the time. Okay, so means I can tell that t directly proportions to g to the power a, h to the power b, c to the power c. So now here I can tell that mm, g in the sense, just before we derive it, right? Unit formula for g. What is the unit formula of, I mean, dimensional formula for g? For g, dimensional formula is, oh, it is somewhere. Instead of searching, we can derive this again. Okay, na? So g dimension formula. Let me derive once again here. Right? G dimension formula is nothing but f into r square by m square. G m1 m2 by, yes, this is the dimension formula for, by using this m l t power minus 2 r square in the sense l square and m square. So I can write m to the power minus 1 l cube t to the power minus 2. So this is g. Coming to h, Planck's constant, E is equals to h view, h is equals to E into t. Right now, view is nothing but frequency, the reciprocal of time variable frequency, that is why Et. So for energy, ml square t power minus 2 for time t. So ml cube t power minus 2 is the dimensional formula for, okay. And next, c is the speed of light. Obviously, L to the power minus 1. This is the dimensional formula of C. Now let's substitute all these in this equation. If you substitute all these in this equation, then you will have T proportionals to D proportionals to G to the power A. G to the power A means G is M to the power minus 1 L cube T power minus 2 whole to the power of A, and H in the sense ml cube t power minus 2 whole to the power b, and c in the sense, sorry, c in the sense l t to the power minus 1 a to the power c, right? Now t power 1 proportions to m to the power minus a l to the power of 3a t to the power of minus 2a m to the power b, l to the power 3b, and t to the power minus 2b, and l to the power of c, t to the power of minus c, right? So from this, what the equation that we will get? T proportions to m to the power minus a plus b, and l to the power 3a plus 3b plus c, right? And next t to the power minus 2a minus 2b minus c, right? From these, you have to find out, you make the squares here. This side you can write m to the power 0, l to the power 0, means, yeah, minus a plus b is equals to 0. So b is equals to a. And next, 3a plus 3b plus c is equals to 0. Okay. In the place of 3a plus 3b now. 3a, 3b. Yeah. So 3a plus a is equals to b now. 3a plus 3a. 0. So 6a plus c is equals to 0. And next, minus 2a minus 2b minus 2a. In the place of b, I'm substituting a. Okay, na? That is equals to 1 here. Minus 4a plus c is equals to 1. Okay, now minus 4a minus 1 is equals to c. Take the c value, substitute in this. Then 6a minus 4a minus 1 is equals to 0. Then 2a minus 1 is equals to 0. So from this, 2a is equals to 1, a is equals to half, right? We got a value as a half. If a is half, then b also is equals to half only, right now. Now what about c? If you take c, from this you can substitute. A value is half, b value is half, and then c value. C is equals to minus 6a. That means minus 6 into half means 3 times. So minus 3. Now what is the relation we got? T directly proportional to g to the power a, h to the power b, c to the power c. So we can tell that c is equals to some constant proportional to some constant into g to the power a. G to the power a, in the sense a value is half. So g to the power half and h to the power half, and for this. Okay, you can't write root for cube na. Means you have to write root gh by c. Okay, so now there are three important points I'll tell you. First point is, sorry, yeah, here it is. Okay, the first point is, all trigonometric ratios don't have dimensions, means dimensionless quantities. For example, if they give sine theta, dimensionless quantity here. Okay, all trigonometric functions, sine theta, cos theta, they don't have any dimensional quantities. At the same time, for example, if they give sine AB by C, if they give, then inside whatever the physical quantities A, B, C are there, they must dimensionless. Because of that, whatever the dimensional for AB will be, the same dimensional for the C also, both will be cancelled each other. Okay, the dimension of AB will be equal to dimension of C. Okay, na? And next, here, for example, exponentials e power x. Exponential functions don't have any dimensionless. They are dimensionless. So here, if e power x is there, x should be dimensionless. In the some questions, how they give, no? They give it like e power minus t by rc. Means whatever the dimension for rc, then that should be equal to dimension of t. Okay, na? You make them equal and you have to find out. So this is about the units and dimensions. Let us give a small break and I will continue for the errors. Thank you. ఆహా, తిన్నా తిన్నా తినేసి వచ్చి స్టార్ట్ చేశాను. Yeah, please guys, if you have any doubt, can ask me. I'll wait for just half an hour, just 5 minutes. I'll start the errors also. If you have any doubts, please ask me. We will solve them. Okay. Fine. Whatever the system it is, CGS system, yes, the system, whatever the system it is. So, yeah, let's start errors. Let's start error analysis. Okay. Uh, I'll give you with proofs. I mean, with the derivations, I'll give you so that you can easily you can able to calculate all the errors, right? So first of all, what you have to do is first of all you have to know what is actual value or a true value, right? True value. Here, a true value in the sense, for example, you have an object and you are measuring. You are measuring. You are measuring the values on the scale, and then first time you got some value like R1. Second time you got R2. Third time you got R3, and fourth time you got like that. You have measured for n times. Here, the true value is considered as average of all these values. The average of all these values. If you take average of all those values, then it's considered as a true value. Okay, na? Mm, yeah, let's me give a gap, guys. We'll continue that.